Welcome everyone to CS 11737, Multilingual Natural Language Processing. This is a new course, so I'm very excited to teach it and co-teach it together with Yulia Svetkov and Ellen Black. Today we will all be trading off, about 1/3 of the class each, but in the latter parts of the class, we'll each be doing one segment. So first, I'd like to talk a little bit about motivation for multilingual natural language processing, and then we can get into the kind of logistics detail, the class, before then going into kind of like our overview of the kinds of things that each of us are going to be covering throughout. And so I will get started. So this map that I have here is a map that I use in a lot of my presentations. And this is basically a map that doesn't stretch all the way throughout the world, but covers, North and South America, Africa, Europe, and some of Asia. And basically it's from endangeredlanguages.com. And it's a map of various languages in the world, and it's color-coded by the degree of endangerment according to some standard of endangerment. And basically, I like this map for two reasons. The first reason is it demonstrates the incredible linguistic diversity that we have throughout the world. So you can see there are so many languages all over the world. There's over, probably 10 in the region of Pennsylvania, upstate New York, et cetera, that we're all very familiar with, right? A lot of people around here are speaking English, but you'll notice that there are even languages that are kind of native to this area and people are speaking. And another reason why I like this map is because you'll notice that there are a lot of red or orange languages that are listed as severely endangered or endangered. And this demonstrates kind of the level of urgency also of developing not necessarily developing multilingual NLP, but in other words, supporting all of these languages in the world that have, been under-resourced, underrepresented up until this point. So this class, we are going to be talking about building multilingual NLP models all the way from, the very top of the the languages that do have lots of resources all the way down to the languages that have very few or no existing resources as well. So how do we build NLP systems? And the answer has developed a lot. And I'm expecting that everybody here, because it's one of the prerequisites, at least has some experience with an NLP class. So this shouldn't be new news to anyone. There's a couple ways. One way is using rule-based NLP systems. And rule-based systems work okay. And for some tasks, they can be, largely sufficient. So like, for example, if you want to take in a word and determine how it's pronounced in Spanish, this is not a hard task. You largely take the individual letters and then you replace them with their pronunciation in phoneme space or something like this, and you'll get a system that's almost entirely accurate. However, if you try to do the same thing for English, which Ellen complains about all the time, English writing is chaos. You have no idea how a word is pronounced. And if this is the case, you really need an extremely extensive dictionary or a kind of machine learning based system that can take in a word and determine how it's pronounced and predict it from whatever information you have. So nowadays, for very high resource languages, a lot of our systems are machine learning based systems, and they work really well when lots of data is available. However, if we have no data to train our systems on, they work not at all, basically. Or you have to try really hard to get them to do anything reasonable. So, most of our classes, a lot of our classes, and probably this class as well, are going to largely focus on these kind of machine learning based systems on the bottom. And we're going to be, there's a reason for this. And the reason for this is because, language is hard and we need to do most reasonable things with it. We do need to have some degree of learning from data. But this becomes really challenging. So machine learning models, kind of formally, we talk about them as mapping an input X into an output Y. And these can be all kinds of different things. It can be text is our input X. Our output Y is text in another language. So this could be translation. Input X could be text. Output Y could be a response. And this could be something like dialogue or QA or something like that. Input X could be speech, output Y could be a transcript, and this could be speech recognition. Input X could be text, and output Y could be linguistic structure, and this could be, language analysis or syntactic analysis. And when we learn these systems, we can use several varieties of data. So one could be paired data, where we have input X and output Y together. And another thing could be monolingual data. So we have data only on the input side, or data only on the output side, or we could also have data in similar languages. So in a really, fortunate situation, like let's say French to English translation, we might have tons and tons of this data and we can largely rely on the first. But in almost every other situation, including even a lot of interesting applications in English, we're never going to have, enough of the data, the paired data. So we need to do learning in more interesting ways. And I kind of accidentally gave a preview of the slide, but the reason why this is problematic for most languages in the world is that the amount of data that we have is really limited for many languages. So you can see up here, this is a graph of the number of articles in Wikipedia on the y-axis. And the x-axis is the rank according to the number of articles in Wikipedia. And of course, Wikipedia isn't the only data source that we have, but this is kind of, in a way, a representation or, a representation of the long tail problems we have of data. So Wikipedia kind of is representative of the data that we have on the web as a whole in terms of like what distribution we have. And in terms of Wikipedia, at least, after the first 30 languages or so, you can see we have a drastic decrease. After 100 languages or so, we have very little data at all. And after 300 languages or so, we have no data whatsoever, on Wikipedia at least. And because of this, any language that falls beyond the, where we have text, obviously we're gonna have lots of problems in trying to do anything. Like you want to apply the big pre-trained models that Facebook and Google released. These languages are not gonna be included whatsoever. So, yes. So we're going to spend the whole class talking about multilingualism, multilinguality, building systems for languages where we can't just rely on throwing lots of data at this. And there's going to be lots of strategies that we're going to be using. And for each application or each situation, things are going to be a little bit different. But on a high level, we have lots of ways of coping with these issues. So one way of coping with these issues for some tasks is just writing rule-based systems, doing everything by hand. And that's a perfectly reasonable choice for some applications, but you're going to very quickly run into a barrier where you can't do that anymore. So, or can't do it as efficiently as if you were able to do it with machine learning. But within machine learning, we can do better models or algorithms. So we can come up with more sophisticated modeling or training methods. And in order to do this, we'll have to be well-versed in natural language processing, machine learning, et cetera. Another thing is coming up with more linguistically informed methods. So, knowing about linguistics, knowing about the properties of language, knowing about how, all languages in the world are similar in some ways. So like one example being that when we speak with our mouths, usually. In some languages, we may speak with our hands, but, we don't usually speak with our elbows, for example. So because of this, all sounds in languages are usually going to be coming out of our mouths. And so the number of sounds that we can have in a language is also limited by, our physiology. And we can take advantage of this fact. So in one other example is all languages have some variety of recursive structure. So you can come up with a phrase, you can embed the phrase in another phrase, et cetera. And we can take advantage of this fact to come up with better models. Another thing is better data. So every piece of relevant data can help. You'll want to be resourceful. I hope this is something that we can teach in this class as well. So while better models are great, very often just coming up with another corpus that you didn't have before will raise your accuracies by a significant amount. So how can you possibly get your hands on the data that you need to be doing things? And we'll also be trying to introduce this as well. Also making data if necessary. So like if you're from a machine learning background, the idea might be, or you might have been like accustomed to the fact that you have a data set and you want to maximize accuracy on the data set. But the good thing is if you want to create a model for another language or something like that, you can just ask that person, person who speaks that language, to help you out. And if you're in CMU, there's not a bad chance that there will be somebody sitting, down the hall from you that knows that language. And I actually have an example of this where we made a data set for 20 plus languages, and more than 3/4 of the people who helped us make that data set were students in LTIs. So if you're resourceful, you can do things like this as well. And finally, better deployment. So basically, different situations will require different solutions. So, if you're, just because you had something that worked for one language doesn't mean it's going to work for another language, either because of data resources or language features or things like this. So for example, if you come up with a great model of phonetics for a speech and you don't take into account tone, you're not going to do very well on Chinese or Vietnamese, which are languages that require that you know something about tone. Or if you come up with a model for English and Chinese that works really well, you're suddenly going to start running into problems in Russian where you have lots of conjugation or something like this. So there's lots of different situations, and we'll try to make you aware of these as well. So this class will cover linguistics. We're going to be covering, features of language that are useful for building models, including typology, orthography, morphology, syntax, language context change, code switching. This won't be as extensive as a linguistics class, like human language for AI, but we will try to cover the basics. So even if you haven't taken an extensive linguistics class before, you'll have an idea what's going on here. Data, so annotated and unannotated sources of data, data annotation methods, linguistic databases, and active learning, how you can build data efficiently. Tasks, so we're going to cover a very broad variety of tasks. I haven't covered anywhere near all of them in this list, I think, but language identification, sequence labeling, translation, speech recognition synthesis, syntactic analysis. So lots of different things we can be working on. And also, very importantly, societal considerations. So language doesn't exist in a vacuum. It's a medium for human communication. And any language that we're trying to build a system for is a language that is very important to anywhere between millions to many speakers. So this is an important thing to know as well. And the overall goal is how we can build a strong functioning language system for a low resource language, ideally one that you do not know. So I know several languages. I'm going to introduce this in a second. But I'm also able to build a reasonably good translation system for a language that I can't read, all because of knowing these things. So that's all I have for kind of like the very high level overview of kind of the goals of the class, and we're going to go into logistics next. Do we have any questions so far?
No questions in the chat.
Okay. I don't see any, so okay, I'll go on. So I'm going to go through the instructors and TAs next. For each of the instructors and TAs, I'd like you to introduce yourself, maybe say a few words about your research interests, and also which languages you speak, know a little of, or like or something like that. So yeah, Yulia is the first on the list.
Hi everyone, congratulations and good luck in this exciting semester in the course. I'm Yulia, I'm fourth year faculty at CMU, and I did my PhD, master's actually, and PhD at CMU, focusing on the topics of low resource NLP. So the topics of this course are really close to my heart. I worked on multilinguality across various levels of linguistic structure, on semantics, syntax, and also in the tasks like machine translation in different languages, on low resource African languages, on morphologically rich languages like Swahili, Hebrew, and very excited about this class, and excited also to learn from all of you and my co-instructors.
Great, thanks a lot. The next is me. I'm Graham Newbig. I'm fifth year faculty, actually, at LTI. And I started out working on speech and spoken language processing for a very short time and then I fell in love with machine translation and multilingual and NLP. And so I'm also very, very interested in this and excited about this course. In terms of the languages I speak English and Japanese fluently. And I can read a little bit of Chinese, Korean, and Spanish, like enough to, but I cannot pronounce Chinese. It's my lifelong ambition that never gets realized to learn how to pronounce Chinese, so I could actually speak it. So, yeah, actually
forgot the languages. Sorry. So I speak, so my native language is Russian, and since I was born in Ukraine, I also speak Ukrainian, which is similar but different from Russian. And then I lived for, like, I grew up in Israel, so I also speak Hebrew like a native language. And my weakest language is English. Unfortunately, this is a language I communicate with you. And I'm learning on Duolingo Spanish, but it's going slowly. And a little bit, I also was trying to learn Arabic while I was doing research on Swahili Arabic, because Arabic is actually very similar to Hebrew. So I can, once you learn how to read, you can understand a lot of words because the roots are similar. Those are related languages.
Great. So next is Ellen.
So we're seeing a number of years of being faculty. I've been faculty all of this millennium is the best way to describe it. Well, I only came in '99. I primarily work on speech, but I do lots of NLP as well. I have built speech synthesizers for over 800-900 languages. I don't speak all of those languages, but I have some knowledge of them and having processed them. The only language that I have beyond English where I have some competence, well, maybe Scots English as well, is Japanese. Like Graham, I lived in Japan for a long time, way back in the 1990s, and I'm not fluent, but I can read it and get by and have no problem. Many languages on the planet I can understand and do something with because I've just done enough projects now to allow me to be able to do it. These days, I'm particularly interested in Indian languages from the Indian subcontinent. I've done lots of work on dealing with most of the major languages and some of the minor languages. I've also more recently been working on code switching, where people are mixing languages, and I'm going to say more about that because that will actually be included in the course.
If I can add to it just a sentence, because Alan will not say it about himself. So if you have any random question about any language, most likely Alan knows the answer. So this is a person that really knows most about how languages work and what are the languages and how the phonology and linguistics and NLP, everything.
Great. So for TAs, we have Cindy.
Oh, yeah. Hi, everyone. So my Chinese name is Xin Yi, and I usually go by Cindy. So I'm starting my 4th year of PhD at LTI, and I work with Graham for the past few years. And my research has been focusing on low resource MT, and in particular, multilingual MT, and intelligent data utilization methods for multilingual MT. So for languages, I think you can guess that I can speak Chinese, Mandarin Chinese, because I grew up in China. And obviously I can speak English. I've been wanting to learn more languages, but never had the time or mental power to keep it going. So it's been a shame, and I really want to learn more. So in the past, I tried to learn French, also on Duolingo, but didn't go anywhere. And I also really like Italian because I think it sounds really nice. Yeah, that's it.
Great. And Tanmay.
Hi everyone, I'm Tanmay Parekh. So I'm a 2nd year MLT right now. I am primarily working with Alan, but I've worked with Graham and Julia before. My major research areas, I've been trying a lot of different things, but majorly motivated by code switching, multilingual, and I've tried speech recognition and translation before. So that's been majorly my research area. And in terms of languages that I speak, I'm fluent in English, Hindi. I had learned and I can speak and write Marathi as well. And I go away with understanding Gujarati, Marwari, more of the Indian variants on those lines.
Great. And Sachin.
Hi everyone, my name is Sachin and I just started my 4th year of PhD. I work with Julia.
Sachin, we cannot hear you very well.
Oh no. How about now?
It's better, thanks.
Okay. Yeah, so I was saying I work with Julia, and currently I'm working on like translating into language varieties or related languages. In the past, I work on domain adaptation, work on other parts of MT, like speeding up training MT. I'm also interested in working on style transfer. So just working on a bunch of things. So my native language is Hindi and Punjabi, and I speak English, of course. And my roommate here speaks Bengali, so I'm learning to speak Bengali from him. It's not going well, but it's progressing, I guess. Yeah.
Great. So you can see we have a pretty diverse set of languages and interests and stuff like this. And I think one thing that would be useful is we're going to have a project, which I'm going to talk about in a second. And so it's a good idea to like know who the good people to talk to about your project interests are, but we'll also try to introduce people to help you out with that also. And sorry, Sachin's office hours are no longer TBD, but they should be on the website. And actually, trust the website, don't trust this. I think I might have made a mistake here. So.
Actually, my office hours are what Tanmai's are listed as. Okay.
Yeah. So take a look at the website. The website has the most recent and accurate information. With respect to office hours, we are going to be posting Zoom links on Piazza a little bit later. So we'll each have our own Zoom link for office hours that you'll be able to show up at. So cool. So for the class format, we are doing something a little bit unusual this time, and it's half recorded and half interactive. So we're going to have a format where, at your convenience, we have a 30-minute lecture video that you will be able to watch, and this will give you the background. We might have an optional, not every time, but some of the times we'll have an optional reading that you can do before the class. The reading will definitely be posted, or we'll try to post the reading by the end of the previous class, so you have time to go through it. The lecture video we will try to post the day before, at the very least, the day before the class occurs. Then for class, we will be starting the class at 5:40 p.m. So we're scheduled to start the class at 5:10 p.m. But we'll be starting the class at 5:40 p.m. And basically the idea is that if you want to allocate that time to watching the lecture video, then you'll be able to watch the lecture video during that time. So then after that, we will have a 10-minute language in 10. And basically what language in 10 is where members of the class will introduce a language in groups of 2 to 3. So you will sign up for a slot and be able to introduce a language. You can introduce any language you want as long as it's not a language that's been introduced already. This time, Alan is going to give an example of what this looks like, and it's for Hindi. So all of you Hindi speakers are out of luck, and you have to pick another language to introduce. After that, we'll have a 30-minute breakout room discussion or code data assignment walkthrough. And these two things are different things. We'll have different ones at different times. But basically, the breakout room discussion is where we take the discussion questions at the end of the video, and we'll have a smaller discussion where we split into maybe 6 groups because we have 6 instructors and TAs, and we'll try to discuss what we think about the questions. And this will be graded to some extent for participation. So we'll be marking down, when people participate in these discussions. And you'll have to participate in a certain number of discussions in order to get full marks for participation. And then in the last 10 minutes, we'll come back together. We'll come back together as a full group to kind of summarize the discussion, maybe have a very brief overview of some of the interesting points that each of the groups came up with. And if it's the code data assignment walk, for some of the classes, we won't have a breakout room discussion, and we'll just talk about walking through.
趁牛逼个的课，我跟Tony 说好6点。
Sorry, we had an intervention. Cool. So are there, let's see. Maybe I'll just go through the other logistics stuff and we can take any questions at the end. So the grading policy is we'll have class and discussion participation be worth 15% of the grade. The language intent presentation, you only have to do once. It's a 10-minute presentation in a group of 3 or so, like we mentioned, so that'll be 5%. We have 3 assignments. The first one will be on multilingual sequence labeling. It's an individual assignment. This will be relatively easy, I think. It's just kind of to get people used to like looking at multilingual data, running like neural network models using PyTorch if you're not very familiar with this, but also thinking a little bit about the differences between languages and how we need to model them in order to do a good job at like part of speech tagging or named entity recognition or something like that. Assignments 2 and 3 will be group assignments where you'll be given a baseline for multilingual translation or multilingual speech recognition, and you need to use some of the techniques that you've learned in the class to improve upon this baseline. And then the final thing will be a final project, and the project is supposed to be something open-ended and research-oriented, and you will work together in a group, ideally the same group for assignment 2 and 3 later. I had a question about how many students can form a group. I actually don't know if we've discussed this, but in my previous classes, we've always done 2 or 3. I think maybe I'm seeing a thumbs up from Yulia, so I guess it will be 2 or 3. Yeah, and from Alan, so very quick decision, but it will be 2 or 3. Will there be a way for you to find people to group with if you don't know anyone? Yes, that's an excellent question. Previously, what I've done is had a survey where you could fill something out if you don't know who your group is. We'll set that up and give a deadline. It will be relatively early. So then if you have a group, you just tell us who the group is. If you don't have a group, you tell us what you're interested in and we match people up. And that usually works relatively well. There's also on Piazza a looking for group members thread. So if you want to post in that about what you're interested like right now, that's another way to just get ahead of the game on doing that. Oh yeah, so that's most of the logistics stuff that we have for this time. The grading criteria and stuff for all of these, I think very soon we basically more or less fixed the class discussion participation grading criterion. So we'll make this available very soon. For the language intent presentation, Ellen will be giving an example later, and we'll send the grading criterion out. And then all the assignments and projects will, put out when we assign the assignments and projects. Are there any other questions? Okay, I don't see any. So we, as I said, we're going to try to assign the reading assignments and the, like by the previous class, so I'm going to do that now. We'll also post this on the website if it's not already posted. And the video for the class on Thursday is going to be out by the end of Wednesday. So you should be able to, like, for example, if you want to watch the video before reading the reading assignment, you could watch it early on Wednesday and do the reading assignment later on. Sorry, you could watch it early on Thursday and do the reading assignment later on Thursday, for example. Okay, and now that we're done with the logistics stuff, I'm going to turn it over to Yulia and then me and then Ellen to talk about the actual content. So.
Thank you.
I will stop sharing my screen.
Can you see my screen?
Yes.
Great. Thank you. Okay. So I will be covering now a very quick introductory overview of first 3 aspects of what we will discuss in the class, in particular linguistic knowledge, and in general, the concepts of multilinguality and whatever is related to multilingual training. So I guess one of the prerequisites of this class is that you take an NLP course. So can I get a quick show of hands? How many of you took algorithms for NLP or an equivalent NLP course?
I don't know if you can see in the participants list when you're
There are actually many participants, but I see about half of the class, and I don't know if the other half didn't take the course or it's lagging. So, okay, but I see a part. And then 28 participants. So what about others? You guys didn't take any NLP course before?
You said just algorithms for NLP, right?
Yeah, any NLP or an equivalent of algorithms for NLP. So any NLP class.
Which includes my intro to NLP.
Yeah, and
Right.
I got a question of neural networks for NLP counting. I'd say yes, that's fair to say that counts too.
It's also a good test for participation. I'm sorry that people ask about various, so any kind of introductory course that discusses natural language processing. Okay, so I see 36 people raise their hand. Now turn off this flag if, basically keep the hand raised if the course that you took focused only on English and all the examples that you studied were in English. So I expect, basically, I think we are converging to something like 33. So out of 36 people that raised their hand, 33 people studied natural language processing, focusing primarily on English. Although, as we all know, English is not the only language in the world. And there is a good reason for this. And I guess the reason is that first, English is a lingua franca. So this is the language that we communicate in. And it is easy to teach a class and give examples in a language that we all understand. And the second reason is because NLP is a very big and complex field. So language is the most complex phenomenon. Basically, if you understand and control and use the language, you can describe the whole world, and everything that happens in the world, you can describe it in language. And language has a complex structure. It has various levels of structure. And only to teach NLP in English, it is already a very difficult task. And basically to build an NLP system, for example, a conversational agent that only focuses on English, there are multiple levels of processing that you need to take. So for example, for this conversational agent, which is maybe Siri, you would start with speech recognition, and then you will have a model of language analysis, and then you will have a model of dialogue processing and information retrieval and text to speech. And within language analysis, you will have you can have a multiple levels of processing that also corresponds to various levels of linguistic structure. For example, you can work on language modeling and on syntactic analysis and syntactic parsing, and then semantic analysis, named entity recognition, event detection, word sense disambiguation, and then more extensive semantic analysis, for example, analyzing semantic relationships between sentences. And all of these basically correspond to abstract levels of linguistic structure that we as people understand, and we want our computer to understand and be able to process. So this is the reason that in your introductory course you took in English, because this is how it makes it feasible to teach NLP in the first step. But most of it turns out that most of the people in the world today use more than one language in the course of their daily lives. So you can see this chart from Ethnologue. So for example, only in the United States, there are 422 spoken languages. And in India, there are 454 spoken languages. And if you look at the languages spoken in European Union, then the majority of people in Europe are at least bilingual. And the recent studies also and polls show that it is estimated that most children today grow up with exposure to 2 or more languages. So multilingualism is ubiquitous. And the assumption that if we know how to build a system for English, we know how to provide NLP solutions to users in the world, it just does not hold. Because and this is related already to the introduction that Graham gave, that, for example, English is in a sense a typological outlier compared to other languages. So it has a very complex verb system, it has a complex definiteness systems, it has a poor morphology. So you cannot build a system for English and just deploy it for a language, for example, I don't know, Swahili. And going further, this is not like the separation of languages is not only about different languages, which is about 7,000 in the world, but also about language varieties, that there are many thousands of language varieties. So if I ask you which English do you speak, there are many Englishes in the world. So there is a Nigerian English, and Indian English, and Chinese English. And in some papers, you may see that it works on a standard English, but there is no such thing in standard English. So the assumption is that the research is done on white, male, American English, Wall Street Journal English. But we understand that Nigerian English, which is spoken by millions of people, it has unique grammar and unique rules that make it a little bit different from the Wall Street Journal English. So we want to be able to build even English systems that are actually equitably usable by different speakers of English. So then we need to build solutions for 7,000 languages and thousands of language varieties. And then every step of what you have learned on NLP in your previous class becomes much more complicated. So you have learned tokenization. And in English, there is a white spaces between words and poor morphology. So we can approximately say that every word corresponds to a token separated by white spaces. Although it is also a questionable, it is a question if we think about multi-word expressions and other named entities, whether they are several words or one word. But if we look at Chinese, then words are not separated by white spaces. And if we look at Hebrew, Hebrew is a morphologically rich language which appends prefixes and suffixes. And a single token actually represents several words. And then the question of tokenization, the solutions that you would provide on tokenization would be very different than solutions for English. Then the next level of linguistic structure is part of speech tagging. And again, if we look at, for example, compare English and Russian, auxiliary verbs can be very different in English than in Russian. And also every word can have several parts of speech which are not directly mapped into part of speech in another language. And for example, a concept of definiteness, which is present in English, so definite and indefinite articles are not present in Russian. So then syntactic analysis, syntactic parsing, the concept of part of speech and mapping between parts of speech and words becomes also much more ambiguous than when we work with English. Then the question of tokenization in morphologically rich languages like Hebrew, it necessarily requires also semantic disambiguation. So there is now a mix of the concept of between morphology and semantics, because the same word can be tokenized differently depending on the context which it appears in, and depending on the meaning of this token in the current context. And because English is so morphologically rich and it allows concatenations of several bound morphemes, and because we don't use vowels and only consonants, the question of tokenization actually the complexity of tokenization grows exponentially with in our analysis. And then if we, I assume that in your NLP class, you haven't studied morphological analysis very deeply, because morphology of English, there is some morphology, but it is quite poor. And then if we look at this word or a sentence, so this individual token I actually didn't write the language, oh my God, but this is in indigenous, okay, I will post the name of the language. I will try to, Alan is looking. Alan, do you know the language?
Mapudungun for a guess, but I'm not sure.
I forgot the language. So in this case, the concept of the separation between morphology syntax interface is also very kind of complex, because this individual token actually represents the full sentence. So basically, to be able to provide the morphological analysis of words, syntactic parsing for this token, you really need to understand the morphology of, I forget the name of the language, I'm sorry. And morphology.
It's Quechua?
Quechua, yes, Quechua. Thank you, Graham. I'm sorry. Yeah.
I found it by Googling a previous version of your slides.
Yeah, how did I forget the name of the language? Actually, one of the papers that we could read is the Bender rule paper that discusses all papers that talk about their models, and the paper never mentions which language it works on, assuming it's English, of course. Okay, morphological processing, also there are different morphologies. So this is just an example of a Russian. As you can see, the morphological system is very different from the morphological system of Quechua. And I'm just rushing because I realize I need to be done quickly. And also syntactic structure, so subject, verb, object order in English is when we try to map a sentence to subject, object, verb order in Japanese, you can see how word alignment is complex, because just the syntactic structure of sentences is very, very different. And the semantic analysis again, so every language can see the world in a very different way. There are different number of colors in Japanese versus a number of colors on English or in Russian. And there are very different idioms. So in English, it's raining cats and dogs. Today I heard from Emma that in some of the languages, it's raining different entities. Okay, so to summarize, basically we need to understand linguistic structure for 6,000 languages. Most of them are resource poor. So this is a long tail of languages that Graham mentioned. and along many different NLP applications. And for this, what I have given a summary is basically the linguistic, rough linguistic background, what aspects of linguistics that we will be talking on in this class. And then when we understand the linguistic structure of the language, we can also ask a question, how can we categorize languages into different typologies or different families, or how can we define similarity between languages to understand how can we transfer resources from a most useful language? How can we basically train those multilingual models that Graham will talk next? So I gave a rough linguistic background, and now I'm transferring to Graham, who will give a background on modeling side. Thank you, and I'm stop sharing my slides. Graham, you're muted.
So I saw a nice example in the chat that it rains beans in Chinese. In Japanese, I think it rains gravel. It's interesting the various things that it rains in various languages. I'd be happy to see other ones in the chat. So I'm going to be talking a little bit about modeling. I'm specifically going to be talking about some of the individual modeling tasks that I'm going to be talking about. And then I think Ellen will also be talking about modeling for some other tasks like speech. So the first thing that I'm going to be talking about, and also is going to be part of the first assignment, is sequence labeling and classification. Sequence labeling and classification is very, very broadly applicable, and it can cover tasks such as language ID, part of speech tagging, named entity recognition, entity linking. It can also do, sentiment analysis or other things like this. We're going to be talking about probably briefly about sequence encoders and conditional random fields, which are kind of general purpose methods for doing sequence labeling. And one thing I want to talk about pretty extensively is subword encoding and how we handle the fact that some languages might have a rich morphology, like Yulia talked about before, and how we could handle things like that. In terms of data, we're going to be talking about universal dependencies tree bank, which is a tree bank for syntactic analysis of many different languages. And this also includes part of speech tags and morphology tags, which we can talk about as well. And we can also talk about Wikipedia-based named entity recognition and linking, which are examples of how we can easily get multilingual data. I think also in my part, I might be talking about methods to use unlabeled data in order to improve sequence labeling. We're still kind of working out the details, but this includes things like training a language model on many different languages and using that to get better representations that improve our accuracy on these tasks. Oops. Another thing we're going to talk about is machine translation and sequence models. So sequence models are basically models that take in a sequence and output a sequence, and they can be used to handle many different tasks, including all of the tasks that I talked about earlier in my slides: translation, dialogue, speech recognition, language analysis. They're not always the best method for solving these tasks, but they're a method. This includes sequence models with attention and transformers. So if you've already, for example, taken the neural networks for NLP class, these parts might be a little bit redundant, but they I'll try to go through them briefly. And then an interesting thing that we need to talk about in great detail is low resource considerations. So how do we handle the fact that we don't have lots of data to train these models on, and you can't just create an extremely large model and throw all the data you have at it and hope that it's going to work well. Another thing that I'm going to be talking about is syntax. So syntax is interesting because syntax, is the same across all languages in that, most languages in the world, I won't say the same, but very similar across all languages, in that most languages in the world demonstrate a few varieties of syntax, and we can capture these in certain syntactic formalisms like dependency trees or phrase structure trees like this. But at the same time, the syntax of languages across the world is very different. And there's the idea of syntactic typology, which is basically, describing the features of syntax of particular languages. So for example, for English, we have, he bought a car. So we have subject, verb, object. In Japanese, we have kare wa kuruma o katta, and we can see the verb is katta here. It comes last as opposed to in the middle in English. And then in Irish, we have verb, subject, object order. Malagasy, we have verb, object, subject order. And there's all varieties of kind of these variations of syntax, like do you put the adjective before the noun or after the noun, etc. And there are databases of this information. And we can also, consider how could we incorporate this in our models? How could we use our models to learn more about the syntax of language? And finally, I'm going to talk about an important thing like data creation, but specifically data creation through active learning, which is where we specifically create data in order to make our models better. And this can be a very powerful tool if you want to quickly create functional systems in a language where we have very few data resources, or even a domain where we have very few data resources, like legal, like let's say you wanted to build a legal chatbot for Swahili or Bengali or something like that. Even if you have a reasonable amount of translation data, you probably don't have very much legal chatbot data for those languages. So that's another example where it would be useful. Okay, and finally, I'm going to turn it over to Alan to do the last part.
Okay, give me a second. I'll just bring up the slides. Okay, so can you see the slides?
But we can also see the Zoom chat if you want to. Yeah.
Now can you see the slides without the Zoom chat? Yeah, okay. So later on in the semester, I'll be talking about speech. Speech is the most natural form of communication. I know all of you think that speech and language is something to do with text, but actually most languages are not written. Yes, people learn to read and write, but they're often speaking other languages. In fact, I'm going to ask you, put up your hand if you speak a language that you're not very good at writing. And this probably includes many of the Indians in China.
That includes me also, actually. Did we lose Alan? I hope not.
I think we did.
Yeah, we could email him. We'll see how effective.
I mean, he knows probably that he got disconnected.
Yeah, I'm sure he knows that.
I'm back, actually.
Oh,
there we go. Yay. Okay.
I've no idea what went wrong there. Given the lack of time, what I'm going to do though is I'm going to do the language in 10.
Alan, people posted a bunch of responses to your question in the chat.
Oh,
if you want to.
Right. So I've lost all my windows because I had to.
Yeah.
So it's Tamil, Kannada, Punjabi, Gujarati, Bhojpuri. I'm sorry if I don't pronounce it correctly.
Bhojpuri? Oh, right. Okay. Oh, wow. Okay. I need to know that person.
And several people wrote Mandarin. Those people
Right.
who were born in the United States.
Oh, right. Okay. So yeah, second generation is also something that can make this particularly hard. We'll get an opportunity to talk about this later in speech, but what I'm actually going to do, because we're lacking time, is I'm going to do this language in 10. Now, all of you are going to have to do this, okay? I have to bring up the window, just give me a second. So you'll be expected to talk about a language in 10 minutes. And what we're going to do is we're going to do it in Hindi because, you know, I'm perfectly fluent in Hindi. I'm not perfectly fluent in any way in Hindi, but I know a little bit about the language. I'll give you a sort of summary at the end of the way I think I talked about it, because that's something that's important. So Hindi, okay, is a language spoken in northern India. It has somewhere in the regions of about 320 million native speakers. It's always hard to measure what the native speakers is. I was going to put it to be 32 crore speakers, because actually in the Indian subcontinent, people count in a different way than what we do in Western Europe and North America. 1 crore is 10 million. And it's quite normal that you will see the number of speakers of a language that uses lakh, which is a smaller number, 100,000, and crore, which is 10 million, that will use those figures. But what's interesting about Hindi is that there are 320 million native speakers, but there are 270 second language speakers, and they're often very, very fluent in the language. They're using it primarily for communication. It's sort of a lingua franca in northern India and throughout most of India, but in the south, people are not as fluent as Hindi is what they are in the north. Depending on how you count, it's the third or fourth most spoken language in the world. Depending how you count, Mandarin, English, and Spanish are above it. But it's still a low resource language, which is a little weird when we've got 500 million people who are actually speaking it and using it daily. It's taught in schools throughout all of India, and so people certainly have a familiarity with it. We should at this point say something about Urdu. Urdu is another register of what could arguably be the same language. Urdu really is distinguished actually partly on how it's written from Hindi. Urdu is written in a Perso-Arabic script, and there's certainly a religious distinction between it. People who are Muslim will refer to the language they speak as being Urdu, while people who are Hindu will refer to the language that they're speaking is Hindi. Even though it's mutually intelligible, it's not always mutually intelligible, but it's in the same sort of space that maybe American English and British English are. Everybody knows when you're speaking one or the other, but it's not actually a problem for most of the cases to actually understand. However, when you write it, people may not be able to read the other one, not just because it's a different script, but because they will use different words, and there's a literary register that gets used, and Urdu in general will have more Persian Arabic words in it, where the Hindi speaker is less likely to recognize that, and the Hindi speaker is more likely to actually use Sanskrit-based words. So there's a little bit of separation in the writing, but most of it they can read and write with no problem whatsoever. Importantly, they share mostly the same phonology. So a speech recognizer would work for both. And the grammar is basically the same. Hindi is Indo-European, so there's some cognates between European languages and the Indian subcontinent. When you move further down in India further south, that's not the case, but the northern ones have a overlap. So for example, if you take the word Maharaja, which you may have heard because it appears in English, it means something like the important king or a super king, a king above a king. But really Maha is the same cognate as Magnus or Mega, and Raja is the same cognate as royal. So it's just a mega royal, okay? And there is an overlap for that, and these actually mean the same thing if we look at numbers. So 1, 2, 3, 4, 5 is ek, do, teen, char, panch. And you can see cognates with European language. Ek appears as I in some languages. A European language, do or two is very similar. Teen to 3, char to katra. And panch is similar to pent that you'll see in Greek or pentagram in English. The script is Devanagari. There's an example of Devanagari there. It's a Brahmi script. It's used for lots of languages in the Indian subcontinent and even Thai, Burmese. Devanagari, as it stands, is used for a number of other languages that are not Hindi, particularly Marathi, that's spoken in Mumbai and Maharashtra, and Nepali, and a number of other languages will often use Devanagari, while Urdu is using this Perso-Arabic form that's called Nastaliq, which is not like Arabic, but it's sort of like Arabic, and therefore it's a little different. And most Hindi speakers will not be able to read it unless they've actually trained in reading Arabic script. However, often on social media, Hindi will be written in the Latin script, an English script. In fact, most Indians will say it's written in English, but what they really mean is a Latin script. The grammar is SOV, so the verb comes at the end, so you get subject, object, verb. Often the subject is dropped. There's what's called the pro-drop language. Japanese is a good example of another language that does that. We have gender for all nouns, masculine and feminine, independent of whether they're actually masculine and feminine in the English sense, but all words have gender. It's a pretty rich morphology language, and it has agreement often between the subject and the verb. And one thing I'd like to highlight in the grammatical form, it has ergative marking. Now, if you've ever taken a course with Laurie Levin, she will have gone on in detail about ergativity because it's really cool. And the answer is it's not actually really cool, but it's just really different from most of the European languages. Most of the European languages, when they have agreement with the verb, they have agreement with the subject in the verb. But ergativity is when you mark the object and make it agree with the verb rather than mark the subject when you make it agree with the verb. There's some other conditions that are based on that, but lots of linguists consider ergativity to be interesting, though actually if you look at languages throughout the world that have markings on verbs to any of their arguments, ergativity is relatively common. It's just not common in the European languages, so often linguists find it interesting. So I highlight that because it's sort of interesting aspect about the grammar, which makes it quite different from other major languages, and therefore it's worth highlighting, and that's something that you might want to talk about when you're talking about something that happens in a language. Now let's talk about the phonology, okay? So this is the phonemes, the noises that are appearing in Hindi. Now, one thing about Hindi has a lot more phonemes than many languages. It doesn't have the most, but it has probably somewhere in the high 80s, while English has something that's maybe in the 40s, while Japanese only has about 25. It has a lot of vowels, and rather interestingly, it's got 3 classes of vowels. It's got this reduced middle schwa, which English has, which is an vowel, which is basically a neutral vowel. It's not any particular vowel, but Hindi has it. Not all of the Indian languages have the schwa. Of all the other vowels, they have long and short versions. So you have to make a distinction between a and ah. Now, in English, we don't really do this. In fact, most European languages don't do that, though German has it. Japanese has it, but Hindi has it. So you have a lot of vowels, and these are quite important. And also in writing in Devanagari, it's actually marked whether it's long or short. But in the Romanized version of Hindi, it's often not marked. So people will just write a single English vowel and expect the reader to know that it's a long vowel rather than a short vowel. So that makes it difficult in doing some form of processing. For consonants, basically in the IPA, we have a nice table for consonants, and whoever came along and decided what Hindi was going to be, they didn't know they had to choose from it, and they just ticked everything. It's not completely true, but it's partly true. It has a lot of variants of a lot of consonants, many more than other languages, particularly in the space of stops. So this is t, p, t, and k, and further back in the throat. And they have more variants than most other languages. Well, actually in Northern India, they almost all have these variants. Nepali actually has more because they have nasalized versions instead, but they make much more distinctions, and probably you may be used to hearing Indians when they're speaking English, they seem to put more effort in some of the stops, the PTKs, than what Americans or Brits are doing when they're speaking English. And that's because they're actually using aspirated versus non-aspirated stops in places that North Americans and Brits would not normally do. It's not wrong. Actually, there are more Indian English speakers than there are any other dialect of English. So arguably they're right rather than the rest of us who are not. I'd like to also highlight a rather interesting thing about Hindi is many of the educated people, which means the people that are literate, which means the people that are online, are actually very fluent in English. It's fairly common among younger people younger than me, that from probably middle school or maybe even younger, they were not just taught English at school, but they were taught in English for all subjects. And so they're very fluent in English. They're technically often not native speakers, but they're effectively fluent in English. And actually many Indians are more literate in English than they are in their native language, Hindi, Marathi. Because they've just had more experience in writing and reading in English. They're still literate in their own language, but they're very fluent in English. This brings in this interesting aspect of code switching, where they're often in a situation where they're speaking to people with multiple languages, and what they'll do is they'll just flip between Hindi and English while they're speaking. And this is not like, say, Japanese that often has borrowed words from English and Japanese. This is actually changing the language while they actually speak. So what they're doing is they're sharing words, they're sharing phrases, they're sharing morphology, they're sharing whole phrases and sentences while they're speaking. Next time you get to stand at a bus stop, if we ever get to stand at bus stops again, listen to the Indian people around, and you'll understand, if you're an English speaker and not a Hindi speaker, you'll understand probably 25 or 30% of the words that they're saying, because they're actually doing code switching all the time. This is called Hinglish, maybe officially. It's not really done in formal situations, but it is done in casual forms in speech, and particularly in online forums, so Twitter, Facebook, Reddit, etc. And this puts an interesting task on us with respect to how to deal with language. It is not Hindi, it is not English. It's something that's mixed, where contextual information is really important, and you have to understand both languages to understand it. So it's actually a challenge in dealing with Hindi, okay? So that was a language in 10, okay? What I touched on was history, geography, social position. So sometimes some languages have got a prestige position, and sometimes they've got a casual one that would not be used in any formal form. English is probably not used in a formal form. Talked about linguistic aspects of morphology, grammar, phonology, and particularly highlighting things that are different or interesting, that are distinctive about the language. You want to show something that's sort of interesting about the language. I mentioned ergativity because it is something that's actually interesting. I didn't talk about the status with respect to resources, databases, whether things are online or not, whether they're available. And Hindi's pretty poor, even considering how much of the number of people who can actually speak it. And also interested in influences. I talked about code switching with Hinglish and into English, because that's a very common form of modern Hindi, will actually be mixed. I have challenged my Hindi-speaking students to come up with sentences that are Hindi and have no English words in them, and they're still working on that. It's got to be longer than 2 words, and acha doesn't count, even though it only has 1 word and it is Hindi. And so that's what we're actually expecting in the language in 10. Some of our other classes actually do this. If you're unsure, come and see me, or maybe talk to me about, or Graham or Yulia, about what we think this should be. But you're going to actually choose between this, and you should do it soon, otherwise your favorite language will be used up. And it doesn't have to be a very big language. You can go for very small languages. Okay, Graham.
Yes, so thank you, Alan. That's great. So we had an interesting question about the difference between languages and dialects in the chat. I won't go through it because of the the time. We're running out of time, but if you're interested, you can take a look there. The video will be posted. What's that?
Mostly politics is the
answer. Mostly politics. The technical definition is that languages are supposed to be mutually unintelligible, but Ellen just demonstrated an example of 2 things that are considered languages that are mostly mutually intelligible. So yeah, I think it's largely a political distinction. All the slides will be online very shortly, so I'll collect the slides from Alan. If you could send them to me now, I'll get them posted. Okay, great. And any other questions? We're happy to take on Piazza. I had one final thing, which is I counted the number of scripts in Unicode, and there are 196.
Okay.
But 64 of them are ancient and historic, and 32 of them, were considered for inclusion to Unicode and rejected, including Klingon, by the way. And as a result, there were 101 scripts that were not ancient or rejected from Unicode. So it's almost exactly 100.
Yeah. Quechua and Mapudungun, the one I said, just that should have been a little bit further north, but I got the right continent.
Yeah, so, but anyway, I'll finish up with that. So thanks everyone. Sorry we went a little bit over this time. We should be more or less on time next time, but yeah, thanks a lot, and we're very much looking forward to the class.